In this episode, we are going to go through the system design interview question of designing a reservation parking system garage. In this question, the interviewer just asks you with one sentence, please design a reservation parking system garage. So at this point, you should follow the script for all interview questions, for all system design, for algorithmic, which says that first you should start with clarifying questions, and then based on the clarifying question and defining the requirements of the product, you proceed with the basic design where you show also, it's good to show also your opinions, things that you know, and you could also specify beforehand the things that you don't know on specific case. We'll see this. So we start with the clarifying questions, which leads us to the requirements. Okay, so we're reserving a parking slot, and I'm going to assume the basic things that a car comes into the parking slot, and it's going to reserve a parking slot, so it needs to pay for it, right? And it needs to get a receipt back. So the user could use potentially a mobile app or a web application and pay for the parking lot. And maybe we can also assume, and this is another clarifying question, that we are not going to deal with payment. We're just going to leave it to third-party payment system and verify it with the interviewer. And also we can also say that as this is a parking lot, and how many spaces how many slots do you have in a parking lot? 2,000 at most. So 10,000. So this is not a high concurrency, high scalability question. This is a very highly consistent. You prefer it to be consistent and say this assumption. We prefer here to be consistent, so we'll go with a standard SQL database. We preferably, for example, for these kind of questions, we'll go with a single monolith backend. In the future, we can extend it. So in general, we are just saying that we prefer here consistency to high scalability. So what are the different entities that we have here? We are going to have potentially cars. We are the vehicles. We are going to have users. We are going to have an entity of type a parking slot. We are going to have a reservation entity, and we are going to have a garage entity. And also, how will the system interact? So when the car comes and it want to reserve a parking lot, that the mobile app or the web application will contact an API. So we could have some public points such as reserve parking slot. You can just call it reserve. This is an API. It receives as a parameter the garage that we're going to reserve the parking slot, the duration that we want, and we're going to get back potentially a specific slot ID and specific reservation ID. So another question that we can ask is, are all the parking slots, about the clarifying question, are all the parking slots the same, or should we assume anything? In this specific question, we had 3 types of slots. We had 1, a compact slot for small cars, 2 regular slots for medium cars, and 3 large slots for big cars. So then we ask whether there is a different payment for each such slot and whether there is a different payment for different hours where we could get answers. So there is a different payment for a different car slot, whether it's compact, regular, or large, and there is no other different payment for based on times, etc. And at this point, we could also clarify an assumption that a small car can park on a medium or on a large car slot, but we prefer to keep filling first the smaller slots, as they are much more frequent, and also users would like to pay a little bit less if the smaller car slots is having a payment of less. Okay, so we know that we need to reserve, we know that we have different card slots, and we know that we are going to start with a simple API of reserve where it receives the garage and the duration, it returns the slot ID and the reservation ID. Then we are going to have another public API of payment where it would receive a reservation ID and produce the payment with the receipt and actually do the payment. We're going to maybe potentially allow the user to cancel the reservation, and so we are going to have another public API of canceling the reservation. And we're going to have a bunch of internal endpoints or internal APIs, such as calculate the payment that receives as an input the reservation ID and produces the payment based on the reservation ID. We are going to have another internal API of free slots, where we're going to have a vehicle type as an input and garage ID and receive all the potential free slots. We're going to have another internal API of allocate slot, where we are going to get the garage ID, the vehicle type, and the time that it wants to park, and we are going to receive a slot to allocate the vehicle to. And if we are going to later on support users, so permanent users that we could reserve to them on a daily basis automatically a car slot, parking slot, and we're going to have a create account where we would receive the email, the password, potentially, or an SSO of the users. So we had to sum it up. On the requirement side, we had multiple types of parking slots, compact, regular, and large. On the public endpoints, we had a reserve endpoint, a payment endpoint, and a cancel endpoint. And on the internal endpoints, we had calculate payment endpoint, free slots endpoint, calculate, allocate slot, create account. Okay, now this is not a scale issue. So we are going to design an SQL database, which could potentially be MySQL or Postgres, and we're going to have a few tables. So now let's move on to the design of the table. So first we are going to have a garage with these fields: ID, zip code, rate compact, rate medium, and rate high. The ID is just a standard increasing sequence ID. The zip code is the location of the garage that we could further on use for in the future if we want for to partition the table. And the rate compact, rate medium, and rate high could be 3 separate fields, where each field would contain the rate that we're going to charge for each of them. The reservation table is a separate table where we're going to have a garage ID. Again, this is a foreign key to the garage table. We're going to have a start date and then end time, which are the reservation start and end time, the slot ID that we're going to park the car on, which could be a foreign key to the slots table. And we're going to have a boolean of whether the user has paid or not. So we had the garage table, now we have the reservation table, and now we have the slots table. The slots table, again, is going to have a sequential primary key ID. It's going to have a foreign key to the garage ID because a slot belongs to a garage. The vehicle type that this slot supports, that could be an enum. The status, whether it's already reserved, it's already captured, or it's free of the slot. So we had the table so far, the garage, the reservation, and the slots table. And for repeating users, we could also have a standard users tables and the standard vehicle tables. On the vehicle table, we could have a vehicle ID, the license plate number, and the vehicle type, whether it's small, medium, or large again. And then the users could automatically reserve this place. Now to the flow, the high-level architecture, which is the next step. So the mobile application comes, it contacts a backend server. The backend server would be a simple monolith single backend server, because this is not, again, not a high-scale question. This is a standard consistent question. Usually the questions in an interview do involve scale, but in this one, no scale. So the backend service would just contact an SQL database. In future adjustments, if we would have a much higher read calls to the database than write calls, because many users are going to check if there is a parking lot, if we need to check the database, then we would separate the SQLDB into multiple read replicas, and then we're going to have a load balancer. So the web or mobile app would contact the backend service, ask to reserve a slot. Then this reserved slot would contact the SQL database, which would have multiple read replicas. So for all the reads, we're going to have a good high scale, and this would be done through a load balancer. And all the payments would go to a separate box, the payment processors, which is a third party. So we have 1, 2, 3, 4 5 components. The web mobile is one component, the client, the backend service is the second component, the payment processor is the third party, the third component, the database is the fourth component, and the read replicas are the fifth component. So we could treat it the same as the SQL read replicas and the read replicas and the actual SQL database. So this was generally it. Design a reservation parking system garage. We started with clarifying the questions. What exactly do we want to do here? We want to reserve a place, to give back a receipt, to do a payment, and we prefer consistency. Do we have different payments? Yes, only for compact, regular, and large slots that people park their card, but not based on time. Then we define the endpoints: reserve, payment, cancel endpoint. Those were the public and the internal endpoints, which were calculate payment, free slots, allocate slots, create account. Then we just mentioned that this is not a scale problem. We defined all the tables, such as garage table, reservation table, slots table, vehicle table, and users table. And then we defined the process where the user came to the system with his mobile app, contacted the backend, contacted the SQL database, split to read replicas, go to an external payment processor, and this is it. This is it for this question, for this system design interview question.